we move now to the work for 7.5 in the 2 and 3 unit book, and this is to do with the equations of a straight line. Now there is only one equation of a straight line, but there are a few ways of getting it, and you may, in the textbook, they'll go through the point gradient form, which I'm going to suggest is the only one that you should use. So the point gradient form. Then there is the 2-point formula, which is a lot of work for an often incorrect answer. And the last one is the intercept form. And the intercept form is so rarely used, it's not worthwhile memorising. So we are going to do I'm only going to do one of them actually, that's the point gradient form, that one there, and I'm just going to very quickly go through the other two. Now, what are the other two? The other two are just versions of the point gradient form, just becoming more and more complex. So let's go through and have a look at what we need to do. So the point gradient form let's just go to the textbook, so we've got it here. The point gradient form is that, where it says the equation of a straight line is given by this form, y minus y1 equals mx minus x1, where x1 is a point that the line will go through, and m will be the gradient. So using this, let's go back and let's find once again, we'll use our nice fine fantastic point, which is 4, 5. So 4, 5 is going to lie on the line, and we want the gradient of the line to be, say, 2. So let's draw that line. So here it is, and a gradient of 2 means for every rise of 2, there will be one for forward movement of horizontal run. So the next point will be down there. So 2 and 1, 2 and 1, 2 and 1, 2 and 1, and so on. So the line would look like, nice and neatly, like that. Okay. Now we know that this line would be y equals, the gradient is 2x, and we can see because we did it very, very carefully, that the gradient, the y-intercept is minus 3. So let's see if we can get this equation here, without having to draw the line itself, using the point gradient formula, or as many people call it, the best formula in the world, whatever. Okay, so we call it y minus y1 equals mx minus x1. That's the point gradient formula. And all we are going to use is y1 and x1. x1 is the first number and y1 is the second number, and the gradient is given there. So we just shove these numbers into our formula. So we say y, that doesn't have a subscript, so it's just left as y. y1, this here is the number. So that's the number 5. Equals 2 is m. X, this does not have a little thing underneath it, it's just plain old x, so it just stays as x. The x1, this here, does have a little number underneath it, so that's actually representing a number, and that number is 4. Yep. So that's how we substitute it in. All we need to do now is expand this, so it's y minus 5 equals 2x minus 8. And the final thing that we are going to do is we're going to take this negative 5 and bring it onto this side, and that will give us the final of y equals 2x. And as it comes across, this minus 5 is going to add, so it becomes negative 8 plus 5, which is minus 3. So we got the same answer without having to draw a diagram. So let's just take another example. We want to find the equation of the line that passes through the point. We're going to have something with minus 2 and 6 with a gradient of, let's make it 3. Okay. So we want a line which has a steep gradient, and on that line, somewhere along the line, is the point minus 2 and 6. So writing down the formula, y minus y1 equals x minus x1. That's the gradient point formula. And all we've got to remember is in this formula there are three numbers. Here is the first number, here is the second number, and here is the third. So the things with the subscript, that's the y1, this one over here, is the 6. This one here is the -2, and the gradient, as we know here, is given to us as 3. So all we've got to do is place those numbers in very carefully, and in this case, please remember that there will be, it's always subtracting y minus and x minus here, so any negatives that we find will become a minus minus, which will become a plus. So we get y minus 6, because that 6 there is that y1, m is the 3, and then it's x taking, now x1, the x1 is this one, so remember this is x1 and this is y1, so that would be taking -2. Oops, 2. The double negative here makes a positive, so we get y minus 6 equals 3 outside of x plus 2. Expanding this here, you get y minus 6 equaling 3x plus 6, or y equals 3x plus 12. So that's the answer there. One final example. So the gradient this time will be -2, and the point that we'll go through, we'll just call it A, might be -3, 7. Okay? So don't forget that this point here is x1, y1. These are the numbers that we're going to substitute in. Don't forget also to write down each time the formula, y minus y1 equals mx minus x1. This will make sure that it goes into your brain and it can easily recall during the examinations. So we go y minus, now y1 is 7, m is -2, x take -3, double negative here makes a positive. Y minus 7 would equal, expanding this in, -2x, and then it is -6. We're going to set this time in general form, just to have some practice doing that. So remembering general form has the expression must equal 0, and we have a positive value for the x. So the a is a positive whole number. So that means I'm going to bring this to that side as well as this to that side. So we get 2x plus y, and we get a -6, and we'll be plusing 6, so we'll be -1 equals 0. Okay, so that's using the point gradient form. Now, there is a 2-point formula, so going back and having a look at this one in the textbook. This is a 2-point formula, and as you can see, it's a lot of x's and y's and 1's and 2's, and it's often very confusing and very poorly done in an exam. So one of the ways to get around this is just don't use it. The best way of doing 2-point formula is to use the 2 points to find the gradient first. So going back and doing that, we are often asked to find, with the pen that works, find the equation of a line through 2 points. And let's just say it's 0, 1. Oh, let's actually not use a 0, actually. 2, 1, and let's say 3 minus 2. Okay. Now we can shove that into the 2-point formula. As you can see before, it's, we can put in, where is this thing? Yep. We can put it into this formula here, but that is very, very complicated. So let's simplify the whole thing. Let's just find the gradient. Find the gradient using these 2 points. Now we already know how to find the gradient. The gradient is found by the formula m equals y2 minus y1 over x2 minus x1. And the good part, if you do this separately, it doesn't care which is the y2s and which is the y1s. You've just got to be consistent. So let's do, these are the y2s, so this is the beginning point, and this will be our ending point. So we get this going as 1 take -2 on the top, and 2 take 3 on the bottom. So the answer would be 3 on the top at -1, so it's -3. So now we've got a gradient. So the gradient is -3. And finally, we're just going to use the point gradient form. So y minus y1 equals mx minus x1. And we just got to use any single of the points. We could use this point, or we could use this point. It doesn't matter. Just choose the simplest one. This one here looks nice and simple because it's got no negatives, so let's use that one. So y minus 1, because there's the y1. And the gradient we found over here as -3. And it's x minus 2. Okay. It wouldn't matter if I had used this point, we'll get the same answer when I multiply it all out. So you get y minus 1 equals -3x plus 6, or y equals -3x plus 5. So my suggestion is to, if you get a 2-point question, is to just take the time, find the gradient first, and then simply find the equation of the line using any of the single points through those two. Right, the last thing we have to do is have a look at the point gradient. The intercept form. And this just uses the A and B, where A and B are intercepts on the x and y axis respectively. So looking at this, you'd only use this form if you need to. Do it from a diagram. So if we go back to a diagram, so let's get a diagram here, and let's clear all that stuff off there. And I've got a line that goes, let's say, through here, goes from 4 and 2. Then there is a cut of 2 on the x-axis, and there is a cut of 4 on the y-axis. And the formula is, go back, it's x on A, where A is the x-intercept and B is the y-intercept. So, back one time. So it's x on A plus y on B equals 1. And so that becomes x on 2 plus y on 4 equals 1. And then you just simply multiply through by a lowest common multiple, which in this case is 8. So you get 4x plus 2y equals 8. And you normally have to set this into general form because it's setting it up that way. So it's 4x plus 2y minus 8 equals 0. Now, that's a lot of, well, not a lot of effort, but it could be easily done by using the same formula, y minus y1 equals mx minus x1, because you can simply work out that the gradient here, it's leaning backwards, so its vertical rise is 4 on -2, so its gradient is -2, and you can just choose any point. This point here is the point 2, 0, or you could use this point over here, which is 4, 0, 4, say. And you could use any of these in the formula up here. So let's just do it. So let's just choose this one down here, the 2, 0. So you get y minus, now the y in this case will be 0, equals -2 is my gradient, and x minus 2. And you get y equals -2x minus 4, and we're there straight away in the y equals mx plus b form. And if you have a look at this one over here, the lowest common multiple, by the way, a few moments ago was not 8. It was silly of me, it was actually 4. So I just had to multiply through that by 4, and you would have got 2x plus y minus 4 equals 0, which is y equals -2x plus 4. So it's the same. Oh, wait, no. So it's minus over here and minus over plus. So they're the same. Okay. So those are the 3 different types of formulas that we can use, but my suggestion to you, and I think it's a great suggestion, even if I do say so myself, is simply to use the single y minus y1 equals mx minus x1. Let's now have a look at a few of the questions that you will be having to do in this exercise. The first question here, of course, is simply using any of those questions, of those formulas, and just choosing the correct one. But then most of them are just gradient intercepts, so no problem. But don't forget, as we often do forget, is that when we come down here and we've got angles, the gradient is equal to the tan of that angle. So don't forget that the gradient, oops, let's go back again. Where's that again? That the gradient m, sorry, m equals tan theta. So in this case over here, we have the angle made in the positive direction is 45. So tan of 45 equals 1. So this here has a gradient of 1. Okay. Then after you've done that, you've got a few 2-point formulas up here, and then it's just going to take you through if it's parallel to the x-axis. Don't forget that parallel and to the x and y axis are lines which have the form. Let's just write them up here. So, okay. If it's a vertical line is x equals a constant, where the constant is where it cuts the x-axis, and a horizontal line is y equals a constant, where the constant is where it cuts the y-axis. So the only lines which are sloped are y equals mx plus b. Okay? So vertical lines, x equals constant, and y equals a constant is a horizontal line. Okay, so don't forget that when we are going through question 5. Okay. Some of the other things that you'll be asked to do, what's the equation of the line through this point and the midpoint. So just, this is another way of saying there are 2 points here. We'll firstly find the midpoint between these two, that one there and that one there. So you find the midpoint first. Then after that one, you've got another point. So you can use the point gradient form. So you find the gradient and then use y minus y1 equals mx minus x1. If you want to be adventurous, you can use the 2-point formula. There's nothing wrong with doing the 2-point formula, except that often is misquoted in exams and incorrectly used. Okay, off you go and do 7.5, all of those questions there, and have a go, and hopefully you'll have good success. Thank you.